part 2 of graphing sine and its transformations. This time we're going to look at y equals sine of x minus pi over 2. So you can see we are going to investigate the c value and what happens to the graph when we change that. We know from our other family functions that when we change something within the grouping, then that's going to affect the x and it's going to go left or right. We also know that it's going to go opposite of what it looks like. So you might think this is going to go left pi over 2, but it's going to go to the right pi over 2. So our transformation of the graph is going to go to the right pi over 2. So I'm going to start with my coordinate plane again, and I'm still going to put on my regular period 2 pi. Because I'm going to go to the right pi over 2, that means I'm going to be starting there. So I do want to graph a full cycle, so I have to go beyond the 2 pi, and that would be 5 pi over 2. I kept the amplitude at 1, so we are up at 1 and negative 1. My original point of sine of 0 would be 0, but now when I plug in pi over 2 minus pi over 2 is 0, sine of 0 is 0, and we have our point there. Then that means I've extended it, so I was normally at 2 pi, so now I'm at 5 pi over 2. I was normally at pi, so now I'm at 3 pi over 2. Those are all the zeros of my graph. Cut those in between into our fourths. We're up at our highest point of 1, down at negative 1, and we connect it for a smooth point. We're showing one cycle here. You could go back, and then you could connect it there and show a little bit more. So my range is still between negative 1 and 1, and my domain is still all real numbers. So the shift inside the grouping is going to move it left or right. You have to think about what your period is, and then you have to think about that shift to put that all together. All right, now let's look at the graph of y equals sine 2x. The sine represents my b value, so here b is 2, but that doesn't mean that my period is 2. The b value only helps you find your period. When you look at your original equation, you can't just see your period. So we have a little formula, period equals 2 pi over b. So when I plug that in, my period is going to equal 2 pi over 2, or pi. So you can see by putting a b value of 2 in there, we've made our period shorter. I am still going to draw the same coordinate plane, going out to 2 pi, because if I just made that pi right there, then it's just going to, all the graphs are going to look the same. So we really want to see the effect of the graph. So I'm going to go to 2 pi, pi, and here we have pi over 2. The sine of 0 is 0. When I plug in 0, 2 times 0 is still 0. My period is pi, so I'm going to go all the way out to my period, and I have 0 there. 2 times pi is 2 pi. The sine of 2 pi is still 0. And then if we plug in pi over 2 times 2, that gives me pi, and the sine of pi is also 0. So those are my 3 zeros. I'm going to be up at 1 and down at negative 1, so I'm up here at 1, down here at negative 1. We connect those smoothly for our 5 points, and we have our sine graph. Now you can see the effect. A vertically stretched it and then compressed it, but now B is going to have the effect of horizontally. So our B value is 2, so we are compressing it. So this one is horizontally compressed by a factor of 2. And if you want, you can go ahead. You can go all the way out to 2 pi by adding those other points. And in this case, we have 2 cycles. So 2 cycles are within our normal 2 pi. This graph y equals sine of 2x. We said that b was 2. Notice I didn't have any parentheses because I didn't have a c value. When I wrote my original graph, my original equation, I put the b on the outside, but if you notice here with this equation, I'm purposely putting b on the inside. There's 2 things that are happening here. B in this equation is 2, b in this equation is 2. They are going to have the same period once we figure it out. Don't look at this one too quickly and think about your c value being pi, and it's not going to shift to the right just pi. So what I would suggest you do is factor out that b value so that you can get your equation into this form. So if we do that, we're going to factor out our b, which is 2. We're pulling it outside the parentheses, and we get x minus pi over 2. So now you can see my b is 2, which is going to affect my period, and my c is pi over 2. So we already did the work to figure out that if your b is 2, then your period is pi. We've already talked about graphing c, so this is going to move to the right pi over 2. We're going to try to put that all together with our graph. So my normal period would go to pi. I am going to the right pi over 2. So if I'm going to the right pi over 2, and I plug in pi over 2, that's going to give me 0 times 2 is 0. The sine of 0 is 0. So I am at that point. And then 1, 2, 3, 4, nope, sorry, pi away would be 3 pi over 2, because we said our period was pi. So 1/2 plus 1 pi, and I'm at 1.5 pi. So I'm going to go to my middle and put a point. My amplitude is still just 1. We're going to go halfway in between that. So we are at 3/4 and 5/4. We're up at our maximum. We're down at our minimum. We connect our graph. So this is a sine graph that has a period of pi, and it is shifted to the right pi over 2. You could continue, you could come on back and draw that and draw another part of your cycle, but this is the cycle. All right, who's ready for a challenge? Here we have the equation y equals -2 sine 1/2 x plus pi, close parentheses, plus 3. You can see I have added the negative, which means it's going to be reflected over x. So we're going to save that for last. The part that I recommend first is my shift up of 3. That's my d value. That's going to shift my whole midline up, so I'm away from the origin. I am then going, so this is step 1, is to do your shift of your midline. You can do it in whatever order, but this is the order that works well for me. I'm going to go to my A value as my second step. So I'm going to be up at 2, which is at 5, and down there. But don't put any points there yet because we are reflecting and we are shifting. Step 3, I'm going to think about my B value so that I can figure out my period. If B is 1/2 and my formula is period equals 2 pi over B, then I am multiplied by the reciprocal, which is going to give me a period of 4 pi. So this one is now going to be stretched out. So I'm going to have to add a little bit here. Actually, I'm just going to erase this. Let's erase this. I do still want to see that it's stretched, but I need to have enough room. 1 pi, 2 pi, 3 pi, 4 pi, and we'll go with that. So my period is 4 pi, so normally I would go from 0 to 4 pi, but not quite yet. We do have to take into our account our C, and this is going to shift left pi. So I'm going to come back here to negative pi. So if this was regular sine graph, I would have then moved it left pi, up 3. If it was positive, I would be going up, but I'm going to be going down. So with my transformations from 0, I'm going to go left pi, up 3, put a point there. Now let's think about our period. So if I have 4 pi period, I'm going to go 1 pi, 2 pi, 3 pi, 4 pi. That one is up 3. And then I'm going to cut that in half. So 1, 2 pi, and I'm up at 3. I'm going to cut this half in half. And I would normally, if it was a positive sign, I would be up there. But I have to remember that I'm going to reflect it. So I have an amplitude of 2, so I'm down here at 1. So I'm going down first. Then cut this between pi and 3 pi, and my middle would be 2 pi. So I'm up at my maximum. And I connect my 5 points for a smooth curve. So I have a graph that is reflected over x. It has an amplitude of 2. It has a period of 4 pi. It's been shifted to the left pi and up 3. My range would be from 1 to 5, both included. Hopefully that made sense. You can always rewind and try it again on your own.